Welcome to our MRU YouTube channel. We hope you enjoy the content. Please like this video and subscribe to our channel if you haven't done so yet.
Today we are having a look at the IN-SITU O2 and COe Monitor, Combustion Optimization Monitor. There are many reasons to use an OMS 420. These monitors measure continuously and simultaneously oxygen and combustibles, and are used at all combustion applications, reducing fuel consumption, reducing NOx emissions, safeguarding the environment, optimizing burner combustion, and saving thousands of dollars each year. So why measure O2 and COe? The fuel and air are rationed to produce safe, efficient combustion, with a safety margin for all changing ambient conditions. Ambient temperature, pressure and humidity changes are continuously influencing the combustion. Monitoring oxygen and combustibles means increasing combustion efficiency and lowering heat losses by decreasing the excess air. Continuous adjustment of the air-fuel ratio, lowering the emission of nitrogen oxides, NOx. Boiler safety surveillance and malfunction detection, for example, burner nozzle erosion, damper failure, intake blockage, etc. Fuel consumption decreases when excess air decreases. In a conventional operation, a safety margin is added, higher O2 concentration in the stack gas. The O2 can be lowered when the combustibles are monitored as well, achieving better efficiency and therefore less fuel consumption. Let's have a look at the available OMS 420 models. The OMS 420 Compact, for clean flue gas only. The OMS 420 RT, remote, for all combustions up to 1000 degrees Celsius, available with or without blowback system. The OMS 420 HT, high temperature, for all combustions up to 1700 degrees Celsius with blowback system. The OMS 420 EX, with MRU declaration of conformity to EX Zone 2. These are the OMS 420 features. Compact and reliable, rugged industrial design. Field replaceable transmitter and easy servicing, without removing the probe from the duct. Dust-tight and waterproof enclosure, easy operation and maintenance. No need for reference air, true wet gas analysis. Low reaction time and low energy consumption. Microcontroller-based electronics with onboard graphic, backlit LCD. Linearized, galvanic isolated 2-channel 4 to 20 mA analog output and RS-485 digital data transfer, Modbus RTU. We offer two different sensors, the ZRO2 sensor to measure oxygen only, and the combo sensor for oxygen and combustibles. The ZRO2 sensor. The transfer of oxygen ions can be measured as a sensor voltage, Nernst electromotive force. The combi sensor. The COe electrode is identical to the O2 electrode apart from the fact that the electrochemical and catalytic properties in the signal materials are different, thus enabling combustible components such as CO, H2, to be detected. The features of the heated ZRO2 sensor are: no pumped reference air is needed, fast and true wet gas oxygen analysis, low energy consumption, fast reaction time and low drift, long life in most applications, very easy replacement on site, extremely service friendly. The features of the O2 and COe combi sensor are: two sensors in one body, works similar to zirconium cell but as a non-Nernst version, with increased sensitivity to hydrogen H2 and combustible CXHY. Now, how does the OMS hollow probe with flow guidance function? This is for all probes, except the HT model, which we will cover shortly. Here is displayed during measurement. The design of the probe makes the gas move faster around the wing. This creates a negative pressure at the top part of the probe, pulling the gas into the bottom part of the probe, and into the sensor chamber. The gas flow velocity inside the tube is the same as inside the duct. During calibration, test gas is introduced into the sensor chamber. This passes the sensor and is then blown into the stack. The calibration intervals are user-definable. During blowback, compressed air is blown into the sensor chamber, cleaning the sensor filter as well as the probe tube. The dirt is blown back into the stack. The blowback intervals are user-definable. The OMS is super service friendly. Other manufacturers' in-situ models require some 3 men for 3 hours and heavy tools to remove the probe from the stack. MRU models require only one man for 3 minutes and light tools. We only remove the transmitter, the probe stays in the stack. Let's see how this is done. Only 4 screws need to be removed. To remove the detector from the probe tube stays in the stack. The sensor can be replaced just as easily. Only 4 screws need to be removed to have access to and remove the sensor. The sensor is mounted safely behind the sintered metal mesh filter of the transmitter, which can also easily be removed, using the snap ring pliers to remove the snap ring and the mesh filter. Now, let's have a look at the operation principle of the OMS HT. But first, the high temperature probe can have a probe tube out of in-canal steel for temperatures up to 1100 degrees Celsius, canthal steel for temperatures up to 1300 degrees Celsius, or ceramic for temperatures up to 1700 degrees Celsius. Now, during measurement, compressed air is pressed through a nozzle. This creates negative pressure in the sensor chamber, extracting the flue gas from the stack, and then blowing the gas back into the stack. During calibration, test gas is introduced into the sensor chamber. This passes the sensor and then blown into the stack. The calibration intervals are user-definable. During blowback, compressed air is blown into the sensor chamber, cleaning the sensor filter, and the probe tube. The dirt is blown back into the stack. The blowback intervals are user-definable. The OMS 420EX has some additional features we want to point out. The OMS 420EX has a MRU declaration of conformity for X-Zone 2. Has a special IP65 pressurized cabinet with Z-purge controller. Comes standard with a stainless steel 4-inch ANSI flange. Optional features are automatic calibration, ATEX heater for very low ambient air temperatures, and an ATEX Vortec cooler for high ambient temperatures.
Thank you for watching. Please don't forget to like this video and subscribe to our YouTube channel.